5, instead of doing 5, I think you multiply it by 2, right? And you take it to, I don't know, 20. So you know.
Guys, I know you're talking about math, I'm sorry. Okay, so, we have one more thing to learn for chapter 9. We've done everything that we can for the unit circle. Unit circle is pretty much done. But at the beginning of chapter 9, we linked the unit circle to the sine and cosine waves. The last thing we need to do is transform the sine and cosine waves. Okay, and when I say transformation, I mean shift up and down, shift left and right, vertical stretch, all of those things, like remember your A is your stretch factor, like that sort of thing. We're going to spend a very long amount of days on this topic. No, it's a good thing. It's a good thing because I want to take it slow. We're going to do, I don't know if you noticed on your stamp sheet packet, we're going to do an extension problem. Do you guys know what extension means in education? No, perfect. No, it means we're going to do a challenging problem. I'll show you in a second. But anyway, this is our agenda for today. So what we're going to do is the last topic for chapter 9. It's graphing form of sine and cosine. Today we're going to talk about how the period changes the graph. It's something we haven't had before in any of our graphs. It's very new. And here is your homework. 110, 111, 114, and 115. And here is your joke for the day. See what I did there? Okay. Now we're going to start with something more familiar, unit circle. Okay. And I'm hoping that we have enough background on this for you guys to help me go along. Okay. Okay, so start here. What do I label here, guys? 0, nice. That's a circle. Thanks, Theo. What do I label here, Theo? Yes, okay. But what is pi with a common denominator of 3? A phonogramma. Perfect. Nice. Okay. Nice. Okay. Now, next question, not for Theo, somebody else. Tell me, is pi over 3 going to live in the top half or the bottom half of the circle? Top. Beautiful. Okay. So I'm going to take the top half of the circle, which is much more familiar to us to be 180 degrees, and divide it into 3 equal pieces. So I'm going to make 60-degree pizza slices. Okay. Give me honest feedback here. How is this coming for you guys?
I make the common denominator.
Oh, I see. So that you can label the top and bottom. Okay, that's cool. Okay. Now, where will pi over 3 live in terms of beautiful. Okay, so I want to count it out, even though I know we know what we're doing. 0, 1 pi over 3, 2 pi over 3, 3 pi over 3. I just want to make sure that makes sense to everybody. Okay. Now, next thing is to draw in the triangle. And what special triangle is this going to be? Nice. 30, 60, 90. And how can you tell? That's a great answer. Perfect. How can you tell though? It's a kind of a dumb question that I'm asking you. Yeah, there's 60 right here. Okay. So I talked to Mr. Guinan at lunch the other day, and I said, how much of this do you expect them to memorize? And he said, you guys all know he teaches pre-calc, right? So he said he wanted you guys to know
that if this is 60, he wanted you to know that the long side was across from the 60. The short side was across from the 30, and the hypotenuse was 1. So we might not know that because, I mean, in our by heart yet, because we're in math 3, but by pre-calc, he wanted you to know those things. Okay, now how are my signs looking? Good, because why are my signs looking good? Do you know what I mean by signs, like positives and negatives? Yeah, why is it good though? Nice. Okay, final answer. Oh, I do not actually I didn't do the reference angle. So reference angle is pi over 3 minus 0 is pi over 3. Did I have to do the minus 0, Mrs. Talbot? Do you see where the understanding comes from, though? I want you to see what you're doing here. Okay, last thing, coordinate over up. Okay, on number 6, we are going to start it together. I'm going to have you finish it in your groups, and I'm going to put the answer up. Okay, so back to Theo. Hi, my friend. Okay, this is 0, correct? What would this be? You're amazing. Nice. Okay, now Connor. Would 5 pi over 6 live in the top half or bottom half of the circle? Nice. Okay. So top half of the circle divided into how many equal pieces this time? Okay. So it's a little harder to divide your circle up into 30s. I start with doing the 60s like I did before, but then I split them down the middle. We have not done one of these yet with a 6 denominator. That's okay. Okay, mine is totally not perfect, but it's pretty close. Okay, I'm gonna walk around. You guys work on this. See if you can do it. I believe you. Speaking will be good. Talking, speaking. I know, I know. No, no, there's only 2 options. Check for understanding real quick. What type of triangle did you get? 30 There's only 2 options. Yeah. Okay, and the big hint is. Okay, now I'm gonna ask you to be very deliberate about your sign. This is where Mrs. Talbot would get this problem wrong when she was in high school. Because she would forget about the signs. I'm not even kidding. That is totally what happened. Yeah. Oh, I know. You got that from my side of the family. Okay. So do we all agree that 5 pi over 6 lives here? Okay. Did we all agree that the reference angle is 6 pi over 6 minus 5 pi over 6 is 1 pi over 6? Did we agree on that? Or did you forget to find the reference angle and go right to this triangle? Yeah. Okay. 1/2 negative root 3 over 2. Oh, quadrant 2. Final answer, back root 3 over 2, up 1/2. Okay. Because we could not go without doing a resource page, we have one, but Miss Rice and I are special. We forgot to put it in the packet. So there is a resource page on your table. There's 2 of them. You need one of each. But we're not starting there. Going to start here. Okay. All right. So I'm going to take you back in time to the day that we did the water bottles. And when we did the water bottles, we said that if it was spread out like this, we were walking fast. And when it was close together like this, we were walking slow. So spread out wave was walking fast. Scrunched up wave was walking slow. We have never had a graph that behaves this way yet in math 1, 2, or 3. This is the first time. And this is called horizontal stretch. And this is called horizontal compression. I like to think of it as a slinky. You guys know what a slinky is? Yeah. You pull it out in horizontal stretch, you push it in horizontal compression. What this means for us is that we need a new letter. So we have to introduce a new letter. We know A, H, and K. We've done those a lot, but we need a new letter. And the letter we're going to use is B.
And what you need to know is what the regular situation is. And we've been graphing this a lot in the chapter. If D is one, the cycle repeats itself every 360 degrees or 2 pi. And I want you to think about that because that's how long it takes, how much it takes to rotate all the way around the circle. So this, you should link this back to the unit circle and say, that's one rotation around the unit circle, so it's one cycle of the sine or cosine wave. Yes, ma'am.
The 720 would be 2.
Yep. Okay. All right, what we're going to do though is we're going to change B to make it wider or skinnier horizontally. So we're going to need a graphing form. We're going to write our graphing form in number 107 and write this kind of spread out. So y equals a. You're going to have sine or cosine b x minus h plus k. Okay, so we're going to start by labeling the stuff that we know that's really easy. We're going to start with K. K is your shift up or down. This does not change with a sine or cosine wave. It's this just your usual K. What is H? It's shift left or right, but it is actually going to turn into the start. Okay, now A is your vertical stretch or compression, just like you would expect it to be. And B is your new one, which is your horizontal stretch or compression. Okay, and we're almost done with this for the notebook, but I want to go back in and add the proper vocab for waves. This is all mathematical vocab. So those are explaining what each of the variables are not variables. Those are parameters. What all of the parameters do, but when you're talking about waves in terms of like actual application science, you should use the proper wave vocabulary. Okay, this one is easiest. What is vertical stretch and compression called in a wave? I'm going to give you a hint. The A was chosen for a reason. What's a wave word that starts with A? Amplitude, yes. Okay, that's the easiest one because it's a wave word that starts with A. Okay, horizontal stretch or compression, we call that period. Wavelength in math, we call it period. So fun for me. Yeah, it's great. It's awesome. Okay, shift left and right, we call that a phase shift. Don't worry, it's just a phase. And shift up and down is called the midline, which apparently I can't spell. Okay, now leave a little space here. We're going to come back to this little spot and put something here after we do our resource page. So now grab the resource page that we didn't put in the packet because we're just geniuses. It was over ski week. I texted Miss Rice and I was like, I think we screwed up. And she's like, what? And I was like, we didn't put the 117 resource page in the packet. We had printed all of them already.
And we were like, do we go back? And then we're like, no, no, no. Okay. Okay. So what we're going to do is hopefully have an understanding of what B does by the end of this resource page. I'm going to use my graphing calculator. So you guys do not need to do anything but sketch. This is going to be an art deal. Oh, how much you love the art. Okay. And what I did was I took my calculator and I set it up so that it's going from -1 to 1 and 0 to 2 pi, just like you would expect. And we're going to try sketch as best we can. What I suggest we do here is break up that window into 3 equal pieces like my window is in my calculator here. Doesn't have to be perfect. Okay, now this is one cycle of the wave. So it went up, middle, down, middle. And the period is 2 pi. That means it took 2 pi to complete one cycle. Okay, are you guys with me so far? Okay. Yeah, mine's not good. Not good. Mine is terrible. Really glad that the WASP guy did not watch me draw this. Okay. So, how much of the cycle was completed here? Half. Does it make sense because of what B is? So I typed half X in and half of the cycle completed. So use your mathematical powers of deduction. How much more would I need for it to complete the whole thing? 4 pi. Do you guys see it would do the top half in 2 pi and this bottom half in another 2 pi, which would make 4 pi. So if you want to, you could go like, okay. Okay. All right. Now 2x. What do you predict is going to happen here? Yes. Yes. Excellent. Genius you are. And then it starts to hit you of how many of these we have to like, okay. So split it into 4 pieces. It's 2 cycles every 2 pi. So that means the period is pi. This is my least favorite one of the whole thing. That is a skill I didn't know I needed in life. Okay, so it goes 3 cycles every 2 pi. So the period is 2 pi divided into 3 cycles. Mine looks terrible, but my last year's one looks worse. So I think I improved. Let the gravity of the situation coming up just hit you. Okay, what that means is you have to fit a full wave in each one of these little marks. Yay! No. I don't hate this one as much as I hated the other one, though. Oh God, it's ugly. Okay, so I fit 4 cycles and 2 pi split into 4 is pi over 2. Oh goodness, last one. I'm scared. Okay, I know it's going to be 5 cycles. I know it's going to be 2 pi split into 5 equal pieces. That part's fine. The sketching, though, okay, here we go. I'm going to do this. Okay. Oh God, this is the worst thing I've ever done in life. Okay. Ooh. My gosh, that's ugly. Okay, anyway, that was horrible. B is the number of cycles in 2 pi radians. The period is 2 pi divided into B equal pieces. And B is 2 pi divided by the period. Because of cross multiplication. Okay, so take this, go back to your notebook. Okay, and we're going to add those formulas underneath 107. Okay, for this resource page, just try not to lose it before I stamp it at least. Uh don't try to attempt to put it in the packet. The packet's already too thick. I mean, I broke the stapler already trying to re-staple somebody's front sheet on, so it's not good. Why did they get stapled? Because the copy machine did it with its like superhuman strength. So anyway, okay. Last thing for the day, we're going to do half of this guy. So if you could get out the blue parent graph toolkit page, and I highly, highly suggest that you staple this onto the rest of your parent graph toolkit stuff. I am going to use a highlighter today. So if you have a highlighter, grab one. So today we're just going to do the front side, which is going to be sine. Tomorrow we're going to do cosine, which is going to be the back side. Oh no, it's another person to see how I'm teaching. How am I teaching, Mr. Knight? It's like people just keep coming in and out. Oh, I'm so sorry. I interrupted your.
You know that my desk won't go up no more. Do you know if they fixed that here?
It's usually just like a Control-Alt-Delete situation. Kelly had the same thing happen and she said Nathan fixed it for her. Anyway, okay. All right, you guys. Equation name, sine. Parent equation. Okay, this pen is got to go, I think. Okay, this is going to shock you, but the locator point is HK. Ooh, I know. Okay, and here's the general equation. Y equals A sine B x minus H plus K. Okay, other info. B equals 2 pi over the period. And period is 2 pi over B. Okay, so the first thing we're going to do is graph plain old regular sine. And we're going to state a couple of things about it. So we're going to say the locator point. And do you notice how there's nothing in the parentheses and there's nothing outside the parentheses? So that means my locator point is 0, 0. And the period is 2 pi. Okay, what that means is my wave is going to start here and it's going to end here. The little pi on this has gotten cut off of the graph. So this is supposed to be 2 pi right there. Okay, so my wave starts here at 0, 0. That's the locator point. It ends here at 2 pi. Okay, what does the sine wave look like? It starts at the middle and then goes up, middle, down, middle. So on this one, the amplitude is 1 because there's nothing there in front. So we go up 1, back to the middle, down 1, back to the middle. Okay, and there's 2 things I'm going to ask you to do, for 3 actually. Back up the train and make another wave. Circle your locator point. And the reason we do that is because waves are infinite all the way left and right. So I need to be able to see where you started. And then if you have the ability, highlight the first cycle. Okay. Next one. This one I've thrown in an H. Do you guys remember that we switched the sign in parentheses? So this is saying left pi over 2. Okay, so we're going to list 2 things. We're going to list the locator point, which is going to be negative pi over 2, 0. Do you guys see the negative? Please tell me you see the negative. So that's going to be here. And then the period is still 2 pi. And what I like to do for this is I like to count boxes. So on this particular graph paper, 2 pi is 1, 2, 3, 4, 5, 6, 7, 8 boxes. So I'll go back to my start and go 1, 2, 3, 4, 5, 6, 7, 8 boxes. And really, this is exactly the same wave as this one. It's just shifted back to 2 boxes. You guys with me so far? Okay, now the sine wave goes up, middle, down, middle. Circle your locator point and then continue the wave on both sides. We usually ask you on tests and quizzes to graph as many cycles as will fit on the graph paper. And then highlight your first cycle. Okay, now we're gonna get more complicated. Are you ready? Okay, so let's start with our locator. There's nothing in the parentheses and nothing after the parentheses. So my locator is 0, 0. That's totally fine. The period in this one, though, is not 2 pi. Okay, so we actually have to do a calculation. Period equals 2 pi over b. And this is saying that I can fit 1/2 of a cycle in every 2 pi. So you keep change flip in your mind, and that's 4 pi. What that means for us is we can't graph the whole wave this direction. We're only going to be able to graph the top half of it from here to here. And also the amplitude is 2 this time, so you've got to go all the way to the top.
Feel like for any fraction, feel real multiply the denominator.
Yep. Exactly. Just take those two and multiply. So this is kind of like the one that we did, the second one we did on our resource page, where it's just like stretched out. You can only see the top half. But we can fit the bottom half over here. And I'm only going to highlight the first half because I really want to emphasize that being stretched out. All right, everybody. Couple of things. If we run out of time, it's okay because we're doing this again tomorrow. Also, if I didn't stamp you, I'm sorry. It's just time. But I will definitely have time to stamp everything tomorrow. It should be fine. Yeah. Did you not do the weekend home, or is that what you're trying to? Oh, okay. So last one, y equals negative sine 2 x minus pi over 4 plus 1. As Mr. Guinan would say, I put the whole shebang in this one. Okay. Locator is positive pi over 4, 1. Everybody see where I got that from? Positive pi over 4, comma 1. Okay, so positive pi over 4, comma 1 is right here. You cannot, it's not labeled, but it's half of pi over 2. Okay, period is 2 pi over 2. Do you see where I got the 2 from? In front of the parentheses. So that's pi. Okay, so how many boxes is pi on this graph paper? 4, perfect. So you want to go 4 boxes away, and that's going to end your wave. Be careful with the amplitude because the amplitude is 1, so it's just going to stay between these two. But it's negative. Which means that instead of going up, middle, down, middle, it's gonna start by going down, middle, up, yes. Once you get this drawn in, then you are done.